Hello, programmers. This discussion describes a tic-tac-toe game that is almost complete. You are asked to finish up the coding for a method that tests to see if the game has been won. The project also has some extra credit if you want to make the output display fancier than what is provided in the sample program. Here are the rules for playing tic-tac-toe. The game is for two players using an X and an O. The players take turns placing an X or an O in one of the squares. The goal is to get 3 X's or O's in a row, a column, or a diagonal to win the game while blocking the other player from winning. Create a program using a double-dimensional array and functions that let the player play the tic-tac-toe game. The program is to read a number from 1 to 9 from the keyboard, alternating between X and O. Ask which square the X player wants, and then ask which square the O player wants. Continue until the game is won by either player, or all the squares have been filled with no winner, called a cat's game. Here is a sample game in which X goes first. X's first selection is square number 1. Then O selects square 4. Now it's X's turn, and X selects square 2. O selects square 5, leaving square 3 open for X to select. When X selects square 3, it then has squares 1, 2, and 3, which make 3 in a row, and X wins the game. Feel free to create the tic-tac-toe program on your own. However, you can use the code that is provided to get you started. Most of the program is already written to display the board, input a square selection for X or O, and update the display. The project needs to check for a winner for any of the 8 possible combinations. The code for the program provided is not complete and only checks for one of the 8 winning combinations, a winner for the top row. You need to figure out how to access the double-dimensional array for the tic-tac-toe board to check for the other 7 winning combinations. Although most of the logic for playing the game is in the public static void main method, the code you need to complete is in the check for winning game, and the extra credit points are in the display tic-tac-toe method. I will cover these first. The game is stored in a double-dimensional array named board, located in main. The board is passed to the display tic-tac-toe method and check for winning game method as a parameter when the methods are called. The index is the position in an array. The two-dimensional array named board has an index for row and a separate index for the column. Unlike some languages that use a comma to separate the row and column index when identifying a cell in the double-dimensional array, C and C++ and Java use square brackets for the row, directly followed by square brackets for the column index. Remember that an array index starts from 0. The characters in the array are what the user sees. The program accesses elements in the array by the row and column index. For example, if the double-dimensional array is named board, then square 6 is accessed board, open square bracket 1, close square bracket, open square bracket 2, close square bracket. The first index value is for the row, and the second index value is for the column. Open square bracket 1, close square bracket, open square bracket 2, close square bracket, are the index values for row 1, column 2. The display tic-tac-toe method receives the double-dimensional character array named board from main and uses nested for loops to display the board. When the program first starts, the board contains only characters 1 through 9. As the program progresses, the characters in the cells are replaced by an X or an O, depending on the player's selections. The outer loop steps through the board array with the first index starting at 0 to select the first row. For each row selected, the inner for loop steps through columns 0, 1, and 2 and displays each element from the array using the system.out.printf statement. The format string for printf is quote %c space quote. The %c is replaced with the selected element from the array board. row, column. The space after %C in the format string gives a space after each element that is displayed. Notice that there is a system.out.print open parentheses, quote, quote, close parentheses, semicolon after the inner loop, but before the outer for loop closes. This causes the cursor to move to the next line on the output before starting the next row as part of the outer for loop. The provided code for display tic-tac-toe method displays only characters 1 through 9 or an X or O. You can get 1, 2, or 3 points extra credit for the project by making the display fancier. Here are examples of extra credit points you can receive. The extra credit points are also shown on the lab report form. For 1 point extra credit, all you need to do is to replace the space character in the system.out.printf open parentheses, quote, %C space, quote, comma, board, row, column, close parentheses, semicolon statement with a vertical bar. For 2 points extra credit, a space, vertical bar, and a space need to be after columns 0 and 1, but not column 2. Dashes need to be after rows 0 and 1, but not 2. For 3 points extra credit, you need a title at the top of the game and really make the display fancy as shown on the example. Have fun with this one. Now let's see how the program determines the winner for the game. There are 8 ways to win. You can win by having 3 X's or O's across a horizontal row, down a vertical column, or a diagonal going from left to right or right to left. After you have finished coding the program, make sure that you test each of the winning combinations to verify that the program is working correctly. The check for winning game method receives the tic-tac-toe game board and determines if there is a winner. The return data type for the method has the data type of char. The method returns a character dash to indicate no winner, or returns an X or an O to indicate the winner of the game. The main program uses this return value to decide if the game is over or if a winner has not been determined yet. There are certainly more ways to check for a winning game than I am showing here. You can choose to do it any way you wish, or you can follow my example. I created a char variable named player to be used when trying to see if there's a winner. There need to be 8 different checks to see if there's a winner. I have only coded a check for going across the top row. Player is set to the contents of the upper right element in the array. Player equal board, open square bracket, 0, close square bracket, open square bracket, 0, close square bracket, semicolon. And then I'm going to see if the same character is present in the next 2 array elements going across. Board 0, 1 and board 0, 2. It does not matter if they are all X's or O's. If they are the same, the game has been won and the value in the variable player is returned back to the main program to indicate the winner. If the code makes it all the way down to the bottom without finding a winner, then a dash character is returned to indicate the game has not yet been won. If you choose to follow the way I am checking for a winner, then you need to provide the additional code for checking the middle row, bottom row, the 3 columns, and the 2 diagonals. Lab project requirements and extra credit. 1. The requirement to check all 8 possible winning combinations has already been covered. The extra credit for updating the display has already been covered. The rest of the discussion covers details on how the rest of the Tic-Tac program works. The main part of the program has code for 1. Use a double-dimensional character array 3x3 for the Tic-Tac-Toe game board. 2. Use a while loop to play the game until there is a winner or all the squares have been filled. 2a. Ask the X or O player for a number 1 through 9. 2b. Convert the number into array coordinates. 2c. Check for illegal input or the square already used. 2D. Fill in an X or an O for the selected square. 2E. Select the next player. 2F. See if there is a winner. 3. Display a message to show the winner or a tie game. Inside main, code is provided to randomly select either X or O to be the first player. This is done using the math.random method. Sometimes it may be confusing when using a random number generator because not all programming languages do it the same. For example, the C and C++ random number generators return an integer from 0 to the largest integer possible. However, Java produces a random number that is a double data type from 0.0 up to but not including 1.0. Multiplying by 2, open parentheses, math.random, open close parentheses, times 2, close parentheses, gives a number from 0.0 up to but not including 2.0, which would be 0.0000 to 1.99999. Then, using the open parentheses int close parentheses cast operator, open parentheses int close parentheses, open parentheses math.random open close parentheses times 2 close parentheses gives either a 0 or 1 because digits past the decimal are lost when converting from double to integer. If the result is the value 1, then X becomes the first player. Otherwise, O becomes the first player. This is not an essential part of the program, but at least I was able to show how math.random could be used. The program starts out displaying some instructions, and then a while loop keeps asking the user to enter a character from 1 to 9 until all the squares are filled and neither X nor O has won the game. The character variable player was set to either X or O by the random number generator on the previous slide. stdin.next open close parentheses gets a line of text from the keyboard. stdin.next open close parentheses dot char at open parentheses 0 close parentheses semicolon gives only the first character on the line, which should be a character from 1 through 9. The next method inputs ASCII or Unicode characters from the keyboard, not integers or floating point numbers. This makes the program a little easier because now we don't need to worry about a data type mismatch if we were using stdin.nextInt open close parentheses while expecting an integer in case the user types some non-numeric data. The user will be inputting a 0 through 9 to select a square in the tic-tac-toe array. The way the program is currently coded, it is using Java Scanner to input characters from the keyboard. We need to remember that these are input as character codes. The ASCII 0 has a binary code of 0011 0000. The ASCII 1 has a binary code of 0011 0001, etc. If converted to their decimal numeric equivalent value, ASCII 0 has a decimal value of 48 or hexadecimal 0x30. ASCII 1 has a decimal value of 49, etc. The program needs to take the user's selection of character 1 through 9 and convert it to index values for the double-dimensional array. The first thing to do is to convert the ASCII 1 through 9 to a decimal 0 through 8. This makes life much easier because array index values start with 0. This is easily done by subtracting an ASCII 1 from the value input by the user. If the user inputs a 3, character 3 minus character 1 gives the result of an integer 2. As a side note, the first 128 ASCII codes become the first 128 codes for the Unicode character set. The next thing to do is to convert the integer value 0 through 8 into row and column index values. It is time to go back and review integer division. When dividing an integer by an integer, we can get two results, the quotient and the remainder. For example, if we divide 5 by 3, the quotient is 1 and the remainder is 2. The percent sign is used to get the remainder for integer division in C, C++, and Java. Use the quotient to select the row and the remainder to select the column. When counting elements 0 to 8, cell 1 is addressed as board, open square bracket, 0, close square bracket, open square bracket, 1, close square bracket. Cell 5 is addressed as board, open square bracket, 1, close square bracket, open square bracket, 2, close square bracket. And cell 8 is addressed as board, open square bracket, 2, close square bracket, open square bracket, 2, close square bracket, 1. Validate the user selection from 1 to 9, which translates to choice being from 0 to 8. If that selection on the board is already an X or an O, the position has already been taken. Okay, space is free, but an X or O based on the current player selection into the selected cell. Increment square counter to keep track of the number of squares used. It is this variable that will be tested to see if all the squares have been used. 5, change to the next player. X becomes an O or O becomes an X. 6, check to see if there's a winner. You need to code the check for winning game method. 7, go back to the top of the while loop to see if square counter is still less than 8 and the game has not been won yet. The while loop ends if all 9 squares are filled or there's a winner. Display the board again and identify either the winner or that it is a tie game. Close the stdin keyboard scanner object and end the program. This is the end of the discussion for the Tic-Tac-Toe game. In past semester, I have seen some really fancy enhancements to the game. The game could be modified so that instead of 2 human players, the other player is the computer. For a simple version, the computer could just pick a random unused square or could even get smarter and compute a winning move or block the human from winning. You don't need to do any of these enhancements. Your only requirement to complete the lab are to test to see if the game has been won, or even do the extra credit for a fancier display of the tic-tac-toe board. Enjoy! See you around.